So we talked about in the first part of the lecture that the shortest path determination could be done by logic, by Dijkstra's algorithm, or by guessing. And I asked you to refer to the link I provided to a YouTube video that thoroughly, in only 10 minutes, goes through each of those. Very well done. Now, in project management, we talk the shortest path, but we actually look at it from inside out. It's the same concept, right? But we're worried about risk in project management. And traditional project management is concerned about limiting risk, managing risk, controlling risk. So it takes the shortest path concept and it actually finds the longest path, which is the shortest time that a project can be done. And that becomes your critical path. So let's see how that's done. You're going to see a lot of similarities of this same concept. So you'll see, don't worry about this slide, I use it for another class, but basically we have the nodes that we've defined, and we'll call them A, B, C, D. And on the right here, notice that we have a start, and then a node A, B, C, D, E, F, and then a finish. It's just like the network diagram or the flow that we were talking in the previous thing. Here we call it a network diagram, but it's the same concept applied. Here is a blown up version of that network diagram. And what project managers do, and it's not part of this course, is they sequence the activities first, right? So the order matters. Something, what comes first, what comes second. So we call it a the predecessor and successor. So A is a predecessor of B, and B is a successor of A. Finish is a successor of C and F, for example, right? And so in the end, we have this picture. These boxes in project management matter. And so right now I've just shown you the activity name here, right? But we'll figure out, remember I said the flow was about duration or time. And so we're going to figure out both here in project management. So when we figure out the duration, we're going to put that in the top, right? And you can see that in these diagrams here. So activity A has a duration of 8 days, we'll call it. Could be hours, could be minutes, doesn't matter. Well, you would define that in your project. B has a duration of 12 hours. G has a duration of 8 hours, right? And then we're going to figure out the early start and early finish and late start and late finish. And in the end, we're going to figure out total float, which is going to define our critical path. Notice on the bottom center where total float is put, anything with a zero float is on that critical path. That becomes the longest path, which is the shortest time that a project can be completed, right? And so you determine the critical path, right, the shortest path that a project can be completed by first doing a forward pass right here. So you go over the top. You start at node A, which maybe starts on day 1. You can define that day 1, day 0, doesn't matter. It has an 8-day duration, so the early finish would be, see early finish up here, would be day 9. If A ends at 9, then B and C can both begin on 9. Well, B has a duration of 12 days, right? See the duration up here? That's where that's at. And so it's going to have an early finish of 21 days. But C, which also starts on day 9, the early start, has a 16-day duration, so it will finish on day 25. And you continue to do this over the top. It's called a forward pass until you get to the last day. Now notice there are a couple of constraints to note, right? So where D goes into both G and H, right? That D has an early finish of day 35. So G can begin on 35 because it's the only one where D goes directly to. But D and E both go to H. So we actually have to wait until both D and E are done. And that's why 38 is used on H instead of 35. Because yes, H was ready for D at day 35, but it had to wait until E was also done because both are required for activity H to begin. The same for I. I has to wait until G, H, and F are ready. And so the early finishes are 43, 52, and 44. So they've really got to wait until day 52 until for the early start of activity I. It's got to wait until all three are done. And that's the forward pass. Similarly, we do a backward pass, which is noted here. A backward pass takes you through the bottom. And what I do is I just notice here to start the backward pass, I take the last day of the early finish on the last activity, last node, and I just drop it down. And I do it backwards, except instead of adding the duration on the forward pass, here I'm going to subtract it on the backward pass. So this has a late finish. Notice the coding here of day 64. I'm going to subtract this time instead of adding 12 days because it's a backward pass. And it has a late start, which is the coding here, of day 52. Now 52 goes into G, H, and F because it's doing the same paths but backwards, and you would subtract from there and continue to do that. This is a big picture, so there's the forward pass, what early start means, early finish, late start, late finish, which you do on the backward pass. Okay, so I just wanted to share that with you. Now here is an example of how this would really work, okay, and I hope that this is useful for you. Okay, so basically we have already figured out our nodes A through F, and we have decided the durations for each node, how long it's going to take to do those nodes or activities. And so A has a 2-day duration, B has 4, C has 3, etc. And so what I'm going to do is I'm going to start on day 1. I could start on day 0, but I chose start on day 1. A has a 2-day duration, so its early finish would be day 3, right? And that becomes the early start of activity B. Early B has a duration of 4 days. The early finish becomes day 7, and the early start of activity C becomes day 7. This is all part of that forward pass. And you could figure out the rest, right? Now, what goes in the early start of activity F? Well, we don't know yet because you see the C and E converge on F, and both are going to have to wait. So we've got to figure out the forward pass of the bottom. So if A has an early finish of day 3, that becomes the early start of delta. Add 3 gives it an early finish of 6. That early finish of delta at 6 becomes the early start of E, etc. Now, what is the early start of activity F? Well, it's got to wait until both C and E are done. So it's day 10. I had 2 days duration. The shortest time that I can finish this project is in 12 days. We still don't know the critical path yet because we have to do the backward pass, which is just dropping down the 12 from the early finish, and now it's a late finish of F, and we do it backwards on the bottom, except we subtract instead of adding to it. And this is called, again, the backward pass, right? So we take 12, we subtract 2 days, gives us a late start of 10. That late start of 10 becomes the late finish of node Charlie, minus 3 days, etc. And again, we end up at the same point. What is the late finish of A? Well, we don't know because we have to wait until B and D are determined, right? Whenever there's convergence on the paths, that is increased risk, and that's why we have to wait to figure it out, convergence or divergence. So we continue the backward pass along the bottom, and we get to the point where instead of waiting for both and the biggest, you take the smallest on the backward pass. So activity B had a late start of 3, D had a late start of 6, so we're going to go with the late finish of A is the smallest. Instead of, it was the biggest on the forward pass, it's the smallest on the backward pass for the opposite reason. Now I'm ready to determine my early start or my critical path, right? So what I do is I either subtract from any node the late start minus the early start, or my late finish minus early finish on any one. So when I do that on A, I get a zero float. That's what I'm figuring out in the bottom. I get zero. But look at D. If I do my late start minus early start, or late finish, I get the same answer. So that's why I say it's or up here. It doesn't matter. As long as I do one of them, I've got my answer for float. And you can see that activity D and E have a couple of spare extra days in them that's useful for me. That's a benefit to the project manager. But you can see my critical path are where the float is 0. So this is my critical path. This is now the longest path in the project, which is the shortest time that I can finish the project. It's anything with a float of 0. So knowing the critical path is going to help you make scheduling decisions, including trade-offs, right, to expedite. Okay, that was all I had. I thank you for this week, and let's do the discussion, but do the YouTube video so that we're ready to do the math work next week. Okay?